So in this question I'm going to deal with B2 2012 higher levels. So the image on the right shows an abstract metal sculpture which is made from several intersecting solids. Figure B2 shows the incomplete projections of two such solids which penetrate each other. Part A. In the diagram, draw a triangular base is positioned, or triangular base pyramid is positioned with its base inclined at 30 degrees to the horizontal plane. Draw the plan and elevation in the pyramid. Right. So I'll do that. So I want to mark my point there. 30 degrees, go up 60, line across until they intersect. That's it. Then in plan view, I see the 20 here, so I go over 20, mark it up, go up 130. So 130. We're going to join them together. Then to find it in plan, bring them down. The distance out can be whatever you choose. It doesn't say specifically what distance it is. I'd say make the distance between there and there 25, because if you look at that length is 30 and this is a bit smaller than that distance. So about 25, 120 long. Then the middle is 1660. So you can join them there together, and then in the middle there. Right, so I'll do that. So you probably want to set this up to the right of your sheet because you'll need a lot of space afterwards. Okay, so here's my start point. It's angle 30 degrees, up 60 millimeters. Now we can mark over 20. Then we're going to go up 130. It's a point there, so we can connect these together. Now I do these lightly, as later on we'll have to heavy them in. So there's the elevation of the triangular base pyramid. Now to get the plan, just drop the lines down. Okay, so as I said, I'd start this about 25 down. The width of the object in plan is 120, so it's all going to be a hidden detail, which I'll hidden detail it in a short while. Mark up 6. Can connect that, or draw your line in between them, so we can connect these points together. Now, I'll pause and add in the hidden detail. So the hidden detail is added in. Now the next thing we have to do is add the equilateral triangular prism that penetrates the triangular base pyramid. So we have to draw this in. Now it says over 75 in the corner. This angle is at 20, and then it doesn't tell us the distances of these lines, but we're given a cross section here that's going to help us, and this is an equilateral triangle, side length 65, and it's inclined at 30 degrees to the horizontal plane. So I'm going to start drawing that, and then I'll teach you how to find the triangular prism in plan. Okay, so I have to measure over 75 from this corner. Now you can get your protractor and measure an angle of 70 degrees. with your protractor. Now I'm just going to use my adjustable set square. So there, I'm going to mark it on there. Now we'll start. Now I'm going to continue this on, and wherever I choose along this line, I'm going, wherever you decide to choose, I'm going to draw a 30-degree line. Okay, this is for the equilateral triangle, and its length side 65. So I'm going to mark 65 along it. Now, an equilateral triangle, all sides are the same. So I'm going to set my compass to 65. And I can mark in the outline. Now, if I want to get these back now, okay, so if I want to get these lines here, I'm going to bring these 2 points back down. So I'm going to bring them back down. Okay, now this is over 30 and up, so I'll do that. So I'll go over 30 and up. Can I have it add in? Just extend on that line. Oh, I went a bit too far, right? So I can start heavying in some of the lines. Right. Goes heavy. It's a heavy line here in the pyramid. Some heavy lines there. Now we don't heavy these ones in elevation all the way because we don't know where they end yet. Right, so we need to find these in plan now next. Right, so how to find them in plan? Okay, so I'm going to go perpendicular to my projection lines. Sorry there, that's inaccurate. And I'm going to take the distances between these. This is like an auxiliary plan. Alright, now the first point, number 1, 2, 3. Okay, so 1 is the furthest one away from you in elevation. It's the one behind the object. You can see the hidden detail there. And so here's 1 in plan. There's 1 in plan. And that's down 30 mil from this point here. So the corner of the triangular pyramid. So I'm going to go back down 30 mil. And go over there. Right, I'm going to label that 1, 2, 3. To get 2 and 3 now, I'm going to take my compass. I'm going to put my compass up here. So there's number 2. I'm going to mark 2 here, and then I'm going to take my compass and set it to 1 to 3, mark it down here. So that's going to be 1, 2, 3. Okay, now we're going to mark them across. I'm going to drop these down in plan. So 3 goes to 3, 1 goes to 1, 2 is going to go to 2, and then I can complete them by heavying them in. I'll just heavy a portion of them, and then we'll learn how to find the points of intersection on the lines of intersection. Now, to find the lines of intersection, I'm going to look down this way so I can get the triangular prism as an edge U. So I'm going to project all the way down here from my elevation. So this is an auxiliary plan. The reason I'm projecting from my elevation is because the lines are parallel to the XY line in plan, so they're true length in elevation, and when they appear as true lengths and you look along them, they'll project as a point, and when a line projects as a point, the surface it contains projects as an edge. So this is an auxiliary plan. There's my x1, y1 line. I'm going to label these. So I'm going to label this 3, 4, 5/6, 7, 5, 6, 4, 7. Right. So I'm going to take my distances from the XY line down. So I'm going to take the distance to 6, follow 6 along, and mark it in here. So I'm going to take 6, follow it along, mark 6 in. Okay, then 5, follow 5 along, mark it in. I'll extend it later. 4, there. 7 is the same distance out, so I can follow 7 down. Right, then 1 and 3. So 1 there. 3. I've yet to do 3. And then 2. So I'm going to label in the points there. That's 4, 2, 1, 3, 7, okay, 6, and this will be 5 here. Okay, so the points join together. Right, 5 joins to 4, 6 joins to 4, okay, 6 joins to 7, 7 joins to 5, 5 joins to 6, right, 1 joins to 3, and then 4 joins to 7, but it doesn't run through the triangular pyramid. Okay, now I'm going to label these points A, B, C, D, E. So this is a turning point, okay, where two surface crosses an edge, and this is a pierce point where an edge on one solid appears as a point, it pierces the second solid there. Right, so 2 points on the intersection are B and E. So B is on the line 4 to 7. So I can bring B all the way back here until it hits 47 in elevation. So there's point B. Now if we want B in plan, it hits 47. So I can bring it down until it hits 47. Okay, same with E. So I'm going to bring E over until it hits 47, and then E down until it hits 47 in plan. There's point E. Okay, now if I want to find A, right, I'm going to draw a line, something called an element, from 4 through point 3 there until it hits this bottom here, line 5 to 7. Right, now this line is called an element, and I can find that element in every view, and it's going to contain point A. So I'm going to bring the bottom of the element back to elevation. So I bring it back until it hits line 5 to 7. Okay, and where it hits it, it joins to 4 like it joins in this view. Now it contains point 3, so I follow 3 back along here, and that's point A. Now if I want to find that in plan, I just drop A down until it hits it, line number 3 here. There's point A. Right, so if I want to find point C, I join 4 through the point C and bring it down until it hits edge 7 to 6. To find that line in elevation, I use pure logic. Look, the element hits line 7 to 6, so I bring it back until it hits line 7 to 6 here, join it back to 4 like it does in your auxiliary plan. It joins there. Now we're looking for point 2, or point C rather. So C hits the edge 2, so that's point C there in elevation. Now to find that in plan, I can bring that down until it hits the line number 2, so that's C in plan. Now to find D, I'm going to join 4 through point 1 until it hits the element, or sorry, I'm going to draw an element from 4 through point D, the point of intersection, until it hits the edge 7 to 6. So I want to find the bottom of this element in elevation, so I bring it back until it hits line 7 to 6. Now where it hits it, I join it back to 4, and it contains point number 1, so I'm going to follow 1 till it hits here. So this is point D, and then to find D in plan, I drop it down until it hits line number 1. So there's D. Now, how do I figure out which is heavy and hidden? The heavy detail will be seen looking in that way. So A to B is going to be seen as heavy, B to C will be hidden as it's behind edge 4 to 7. Okay, C to D will be hidden, D to E will be hidden, and E to A will be heavy. So I'm going to start there. So A to B is heavy, B to C is hidden, C to D is hidden, okay, D to A is, or D to E rather, is hidden, and then E to A is hidden. Right, now 2 goes until point number 2, so there's 2, 3, 1, 2 goes until it touches C, 3 goes until it touches A, and 1 goes until it touches D. Now 3 to A, the line 3 to A that appears as a point here, is heavy in elevation because it can be seen, there's nothing in the way of it. So I can heavy this line all the way to there. It's a bit inaccurate there. Sorry about the background noise there, the students have just got out. Now 2 to C Okay, a large proportion of it will be heavy, but once it intersects 4 to 7, it'll become, or once it passes line 4 to 7, it becomes hidden. So there we go, that's hidden. Right, 1 to D is the same. Before line 4 to 7 it's heavy, and then after line 4 to 7 it's hidden. Now, 7 is heavy until line 7 to E is heavy, and then line B to 4 is heavy. So that's heavy there, and that's heavy. Now, I'm just going to pause that and heavy all that elevation in, and then I'll do the heavy and hidden detail in plan. So I've heavied in the lines in elevation, and now I'm going to go through what point lines in plan are heavy. Right, when I look down, I can see A to B, and I can see B to C, I can see C to D. But lines D to E are hidden by this surface and possibly a portion of this, and so is E to A, that's hidden. So I'm going to heavy, A to B is going to be heavy. Okay, B to C is going to be heavy, C to D is going to be heavy, D to E is going to be hidden, E to A is going to be hidden, now so the line 3 to A appears as a point in our auxiliary plan. 3 to A is going to be heavy, 2 to C is going to be heavy, 1 to D is going to be heavy. Right, now what else is it going to say? This is going to be one single heavy line here. The bottom of the pyramid will be hidden detail. Okay, so I'm going to heavy or hidden detail in here. This portion is heavy then. 6 to 4 is heavy. 4 to 5 is heavy. And this is heavy. Now, 4 to B is heavy. But E to 7 is hidden. So E to 7 is hidden. Right. Now, I'm going to do the last part here. Right, so behind C, I have another point here. I have another point behind A here. Okay, I have another point behind D. So it's where the three edges of the pyramid hit the back face 5, 6, 4. And because surface 5, 6, and 4 appears as an edge, these are 3 points on the lines of intersection. So I can just drop this down to number 2. Drop this down to number 3, and drop this down to number 1, and these are going to join together. So I can hidden detail them. Three, so they can be done as hidden detail. Now, this line is heavy until it passes the edge, becomes hidden. Same with this line, heavy until it passes the edge. Same with this one, heavy until it passes the edge. And there we go. So and that is the question complete. Cheers, thank you, bye bye.